Hello, welcome to Astronautics for Exploit. This is Dr. Ayoshola Ogundele. Circular space economy and market technologies, an offshoot of Earth-based circular economic ideology, a sustainable economic model. For several years, circular space economic focus has been geared towards efficiency in resources use for the space missions development, design, and launching, and reduction in waste brought about by failure space activities. The circular space economic principle stressed that it prioritizes the regeneration of natural systems and the continuous use of resources, moving away from the traditional take-make-dispose linear model. Examples of circular space economic and market technologies are in-situ resource utilization, in space manufacturing, in-orbit servicing, assembling and manufacturing, active debris removal, reusable launch vehicles, refueling satellites in orbit, orbital recycling, robotic manipulation, commonality and modularity in design, and space tracking and situational awareness. In-orbit servicing, assembling and manufacturing is crucial for a circular space economy where resources are continuously reused and repurposed, reducing reliance on Earth-based launches and enhancing mission longevity. Circular economy encourages designing space technologies for durability, repairability, and modularity, extending their operational lifespan and decreasing frequency of disposal. Development of space technology and infrastructure for refueling satellites in orbit, extending their operational life and reducing need for replacements are important drivers of circular space economy. The focus points are as follows: linear space economy versus circular space economy, and circular space economic technologies. Linear space economy versus circular space economy. A linear space economy follows a take-make model, extracting resources, using them once, and discarding them as waste. In contrast, a circular space economy aims to minimize waste and maximize resource utilization through reuse, recycling, and refurbishment throughout the life cycle of space-related activities. In a linear economy, resources are treated as finite and are extracted to be used once. A circular economy focuses on minimizing resource extraction by maximizing use of existing resource through reuse and recycling. Artist's illustration of circular economy is shown in this picture. Linear model view life cycle of a product as a one-way process from production to disposal. Circular model aims to keep products and materials in use for extended periods, extending their life cycle. Linear model generates significant waste, while the circular model prioritizes reducing and eliminating waste through various strategies. Artist's illustration of linear versus circular economy is shown in this picture. Circular space economy and market technologies are as follows: in-orbit servicing, in-space manufacturing, 3D printing and adaptive system, robotic and automation, AI and machine learning, end-of-life management, in-situ resource utilization, active debris removal, and design for disassembly. In-space manufacturing is crucial for a circular space economy where resources are continually reused and repurposed, reducing reliance on Earth-based launches and enhancing mission longevity. Shift from a linear system to a circular one promises significant economic and environmental benefits. Space manufacturing market is illustrated in this picture. Roles of space manufacturing in circular space economy as follows: waste reduction and resource optimization. In-space manufacturing aims to minimize waste by utilizing local space resources and recycling or repurposing existing materials, reducing the need for launch and new resources from Earth. Lower costs and enhanced capabilities. By building and assembling structure in orbit, in-space manufacturing reduces launch mass and cost, enabling more capable and complex structures than those constrained by launch vehicle dimensions. Breakdown of the in-space manufacturing sector of the space economy is shown in this picture. In-orbit servicing is crucial for establishing a circular space economy, enabling extension of satellite lifespans, debris removal, and in-space manufacturing and assembly. In-orbit servicing can refuel, repair, and upgrade existing satellites, significantly extending their operational life and reducing the need for new launches. In-orbit servicing role in circular space economy is shown in this picture. In-situ resource utilization plays a fundamental role in the concept of a circular space economy by enabling sustainable and self-sufficient space exploration and development. By utilizing resources already present on celestial bodies, in-situ resource utilization helps to reduce the need to launch materials from Earth, cutting down on waste and debris associated with launches and spacecraft. Artist concept illustrating in-situ resource utilization is shown in this picture. ISRU focuses on collecting, processing, and using local resources for various purposes, including life support, fire production, and construction materials. Ability to regenerate resources in space, such as converting carbon dioxide into oxygen or extracting water from lunar ice, form the foundation for closed-loop life support and manufacturing systems, essential for long-duration missions and settlements. Artist concept illustrating in-situ resource utilization is shown in this picture. End-of-life management. By recycling, reusing and repurposing space debris and decommissioned assets, end-of-life management aims to drastically reduce the amount of waste generated in space operations, and this helps to reduce the need for extracting new raw materials and minimize energy. Circular economy encourages designing space technologies for durability, repairability, and modularity, extending their operational lifespan. Space debris theft is shown in this picture. 3D printing allows for the production of parts and components directly in space, thereby reducing the need for extensive pre-launch manufacturing and transportation. By enabling on-site manufacturing and recycling, 3D printing can significantly reduce the cost and complexity of space missions. Circular economy 3D printing is shown in this picture. Robotic and automation are very critical in enabling a shift towards a circular space economy, where resources are reused, recycled, and repurposed rather than discarded. This paradigm shift has significantly economic and environmental implications for sustainable space activities. Integrating robotics and automation into circular space economy offers opportunities for innovation and sustainability in the space ecosystem. Challenges such as high development costs, airspace environments, and the need for dedicated infrastructure must be addressed through continuing research. Synergies between circular economy and robotics towards a sustainable and automated future is shown in this picture. AI and machine learning play a crucial role in enabling and accelerating transition towards a circular space economy by optimizing processes across the entire product lifecycle. It helps designers create products, components, and materials that are easy to reuse. Roles of AI and machine learning in circular space economy is shown in this picture. Active debris removal is crucial for a sustainable and circular space economy. It involves actively removing defunct satellites and other debris from orbits, preventing collisions and ensuring long-term viability. It helps to minimize the risk of collisions between active satellites and space debris. Astroscale's achievement of 15 million approach to space debris is shown in this picture. Design for disassembly. It involves designing products and structures for easy dismantling and material recovery at the end of their lifespan. It is a critical enabler of the circularity in the space sector. Fasteners like screws and clips instead of permanent joining, like welding adhesives, enable easy and damage-free separation of components. Artist concept illustrating design for disassembly principle is shown in this picture. For more information, contact Astronautics for Exploit. You've been listening to Circular Space Economy and Market Technologies, an offshoot of Art-Based Circular Economic Ideology, a sustainable economic model by Dr. Enshola Ogundele, with the focus point, linear space economy versus circular space economy, circular space economic technologies. Thank you.